Okay, we're going to walk through the Hwa Chong paper 1, 2024 H2 Math. So let's run through it quickly. The curve y equals to fx cuts the axis at these 2 points where p is a constant in this range. It is given that f inverse exists. State if it's possible to do so, the coordinates of the points where the following curve cuts the axis. So basically, if after the translation, okay, you only need to write down for all this graph, right? You only need to write down the points where they are either on the x or the y axis, meaning where the curve cuts the axis. Understand? So if it's y equals to fx plus 1, right? So what it means is that you translation in the positive y direction by 1 unit. Agree? So you will notice that so the y coordinate, the x coordinate here remains the same, but the y coordinate here, you add 1, you get 1 over p. So this is the point 0, 1 over p on the curve y equals to fx plus 1 that is on the y-axis. Understand? However, for the other point, note, if you translate in the positive y direction by 1 unit, it would be 1 minus p stays the same, but 0 plus 1, but this does not cut the x-axis. Got it? So that is pretty much it. Okay. So 1b, y equals to fx minus p, which means that you think of it as you replace x with x minus p. So that means that translation in the positive x direction by p units. So now I take this point, okay, the y coordinate stays and the x coordinate you add p. So this is a point on the x-axis. Okay, note for the other point, okay, you add p to 0, the y coordinate remains, it doesn't cut the y-axis here. So that's it. Okay, part C. Here what we do, right? There is 2 stage. Okay, again, there are many answers to graph and graph transformation. So this is just one of the many. Okay, so we translate in the positive x-axis by y unit. So we basically just replace x with x minus p. Remember, what you say is what you do. That is the English statement here. And then what? You replace the opposite. And then now you scale parallel to the x-axis by a factor of 1 over 3. So here you do the opposite. So you'll be replace x with 3x. Got it? So we arrive over here. So then by the English statement, we apply exactly what we do. Whatever we say in English here is exactly what we do to the curve and also the point. So 1 minus p, 0. Under the first action, it will take 1 minus p plus p, give me 1. The y coordinate remains at 0. Then the second action, we scale the x-axis by a factor of 1 over 3. You take 1 times 1 over 3. And then the y coordinate remains. So this is a point on the... So when sub y equals to 0 means that it cuts the x-axis. So this is a point on the x-axis. Understand? But note, for the other point, right? 0, 1 minus p over p. You combine the two, right? Okay, you will get this point. Okay, you go and figure this out. It does not cut the y-axis. Got it? Okay, part D is generally the easiest. You want to find the point which is the inverse. Basically, given the point over here, these 2 points over here on y equals to fx, you just swap the x and y coordinate. That's it for part D. Are we clear? So that is question 1. Okay, question 2a. It is given that fx and gx are non-zero polynomials. When solving the inequality fx over gx is at least 1, a student writes fx is more than or equals to gx. Comment on the student's working. So you never ever cross multiply or multiply the denominator over for inequality. So when you can do that is when gx, the denominator, is strictly positive for any x value. Then you can multiply it over and say that fx is at least gx. Otherwise, you can't. Got it? So this question would likely come out in your A-level. You must remember that it's a giveaway question. And if it comes out, you must get full credit. Never cross multiply, never multiply denominator over. So for part B, if you are asked to find the exact set of values of x for which 2x squared minus x minus 9 over x squared minus x minus x minus 6 is at least 1, you bring the 1 to the left. Okay? Work through the algebra, and then once you simplify already, I leave all the algebra to you. the important thing would be to factorize it into many linear expressions. So here you use a square minus b square. Here you factorize as per normal. You identify the critical values that make all these linear factors 0. So the critical value are -2, minus square root 3, and 3. Okay, depending on how you want to present your method. Yes, in my tutorial, I did do a table, but you can draw a number line. Okay, so a pro tip for you is that this is more than or equal to 0. So when x is square root 3 and minus square root 3, you have the expression over here equals to 0. So I put a circle, I shade it, I label it as minus square root 3 and square root 3. Now, if x is 3 and x is minus 2, you will have division by 0. So I put a circle. Okay, did I erase something? I think I erased something. So you put a circle, you do not shade it. Okay, you do not shade it. So that you make sure that that is a circle without shading it, so that you make sure that there is no division by 0. You understand? And then you test the value in between here, 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 and here. You put it in here, you check the sign. And then you can label the plus minus. And then they want at least 0, meaning positive in some way. So x is a member of real number where x is less than -2 or between minus square root 3 and square root 3 inclusive, or x is strictly more than 3. Any question on this? Okay, straightforward. We're going to keep moving. So it's like a recap for you. You just need to know all the standard stuff, and then A-level, just be very careful on this type of question. I'll go very fast. Okay. Nothing else. We go to question 3. The region bounded by the curve with equation given as follows. Okay. X equals to y over square root 2y minus y squared. The lines y equals to 1, y equals to 1.6, and the y-axis is rotated through 2 pi radians about the y-axis to form a solid. Find the exact volume V1 of the ornament, giving your answer in terms of pi. Okay, so for this question over here, right, what you do is you will do the volume of revolution about the y-axis. So it will be V1 equals to pi, and then you do the definite integral from 1 to 1.6 because you are doing relative to y, so dy, and then you do the x squared. Follow so far? And then you have x squared over here. Okay, you walk through the algebra yourself. Not much comment about here. Okay, but what I do want to emphasize is this step over here. From here to here, right? Very important. So probably you can put a star here. So what you do, right, when you realize that you can't integrate, anyway, my focus has never been algebra when it comes to the end of year exam already. By now, you should know how to do the algebra, so not much comments. But this step, I would like to emphasize. So what you do, right, is you split into 2 fractions. Okay. So what I did here was, maybe I can write, the answer don't have, but I'm going to write it here. So what I do, right, is I purposely write like that. I write it as minus bracket 2 minus y plus 2. Can see or not? Over 2 minus y. So the numerator in essence is still y. Do you agree? Okay, because it's minus 2 plus y, minus 2 plus y plus 2 is y. But what happens here is that this will become my minus 1, and then I'm left with a numerator with a constant. That's the key. Then now I can integrate it, which is this step over here. Now when you take the integral, right, you actually here no need to put the modulus, just a small comment, because your value of y, the values of y here, right, is positive. Okay, but then the student will ask me, then should I or should I not put the modulus? If you put the modulus, you're not going to be penalized. Okay, so my advice is just put the modulus if you always think that you forget. But some questions require you to know that the modulus should not be placed there. Okay, so if you ask me to be very precise, if you know that you are in the range of y, right, is positive, sorry, My bad. I'm not talking about 1 to 1.6. Let me be very precise. After substituting 1 in here and 1.6 in here, right? My overall expression here is positive. Okay, let me be very precise. I'm not saying that 1 to 1.6, then you remove the modulus. Okay, let me correct myself. So after substituting it in, and the overall expression for 2 minus y is positive, then you can remove the modulus. If you can observe that, then you remove the modulus. Can? So it's good to always remember, hey, I integrate this is ln. Do I or do I not need to put modulus? So I don't put the modulus if I know that the expression inside the modulus is always positive. Okay, that allows you to remove the modulus. These are the key things I want you to know. Then now you do the integration yourself. I leave it to you. That's the final answer. Okay, you can go back home and walk through the algebra. I only explain the key concepts that you need to know. With that, we go to 3b. An ornament designer designs a different ornament by rotating the region bounded by another curve. Okay, now this equation compared to this equation is that there's an extra b over here where b is more than 0. Everything else remains the same. The line y equals to 1, the y equals to 1.6, y equals 1.6, and the y-axis, all the same. So the question is asking you, if instead of this equation, they use this equation to find the volume when same thing is rotated through 2 pi radians about the y-axis, the volume generated is V2, and they would like you to state the ratio of V1 is to V2. So what you do, right, is you do the same thing. V2 is pi of the definite integral from 1 to 1.6 of x squared dy, same thing. Okay, but this time your x is with by. Okay, now you know that in integration, the constant you can bring out. So you have b squared, you pull it out. Agree? And then you realize that, oh, this is actually my V1. Can you recognize that this expression here in blue is my V1? So the required ratio is just 1 is to b squared. Okay, are we good to go? So that's the old idea over here. Okay, with that, we're going to move on to question number 4. Wow. Okay, 4a. The 11th, 15th, and the 23rd terms of an AP are 3 distinct consecutive terms of a geometric progression. Find the common ratio of the geometric progression. Okay, this is a very standard question that by right you must be able to score. So the 11th term means that it can be represented by, okay, first we define first. Let A be the first term and D be the common difference. So the 11th term is A plus 10D. The 15th term is A plus 14D. Okay, and because they say, okay, I'll continue on. The 15th term is A plus 14D and the 23rd term is A plus 22D. Because they say that these 3 terms are the 3 distinct consecutive terms of a GP, then basically I say that I take the 15th term over the 11th term. That is the common ratio of the GP, right? Must be equals to the 23rd term over the 15th term. And then I have this fraction here. Both the left and the right are the common ratio to the GP, so they equal to each other. Okay, work out the algebra yourself. You will get D equals to 0, which you reject, or A equals to minus 6D. Okay, so A equals to minus 6D. So we still do not know the common ratio, but we only know A equals to minus 6D, right? But we do know that if we sub the A equals to minus 6D back in here, A plus 14D over A plus 10D. Okay, we sub it inside here. So what happens here is the A here, okay, we replace with minus 6D. Then you can find your common ratio for the GP. That's 2. Understand? Okay. 4B, maybe you put a star to remember how to do. Do remember that, okay, let me read the question first. The sum Sn of the first n terms of a sequence is given as such. If they give you the Sn, they ask you to find Vn, right? You simply use the fact that Vn equals to Sn minus 1. That's it. So your Sn is here. Your Sn minus 1 is here. How do we get Sn minus 1? Very simple. We replace all the n here with n minus 1. Understand? So we get n minus 1 plus 2 is n plus 1, n minus 1 plus 2 is n plus 1. Got it? And then here is just your loss of indices lah. I pretty much don't want to go through this, okay? But do take note that this is just algebra here, just indices question. You work it out yourself, can? But I do want to mention one thing, okay? So sometimes, right, I would check for this, you know. So there's an issue with this. Sometimes you require your Vn to start from. So this n term, right, is valid for n starting from 1. You remember that tutorial that we have done before? Where you need to make sure that to check for this, okay? Like for example, your Vn may not be valid for some value, you know. Okay, issue is, right, let's say is if n equals to 1, right? So you have V1 equals to S1 minus S0. You understand? So sometimes, I'm just going to make a small comment about this. You can refer back to the tutorial. Sometimes you need to be very careful on this small little very subtle thing over here that can make a difference. Okay, you do need to check that. So what you need to check is very simple. Can I ask you all to do this? You all check this. Okay, you check that when n equals to 1, right? Does your V1, basically the formula you get here, right? You sub n equals to 1. You check the value. Does it correspond to S1 minus S0 or not? You check. You know where I'm coming from? If it does not correspond, then what you need to do, okay, let me repeat one more time. I say this for a reason. It's not part of this question because this question just nice is nice. When you do this formula, I did mention to you all before, you check the first term value using your Vn. And then after that, you find your V1. So just now you check V1 using this formula, right? By substituting n equals to 1. At the same time, you check V1 is S1 minus S0, right? You check whether this S1 minus S0, is it V1 or not? Okay, if it isn't, then what you need to do is, you say that, oh, Vn equals to 3 to the power of n minus 2n, and it's valid from n at least 2. But my V1 is equals to a separate value. You understand where I'm coming from? This is something that I mentioned in my tutorial before. Correct. You check the first term. This is quite particular. I mention it because it's not part of this question, but I just casually all the time. So sometimes, right, your V1 may not be, so your V1 evaluated from your Vn, right, when you sub n equals to 1, may not exactly be the value of S1 minus S0. Okay, you need to check out for this. When this happens, you need to redefine your V1 to your own value. You clear? Okay. But not applicable for this question, but just to mention to cover everything. Okay. Yep. Let's move on to question number 5a. 5a is quite straightforward lah. By using the substitution x equals to secant theta, where theta is bounded between 0 and pi over 2, show that this is show that the definite integral from square root 2 to 2 of 1 over square x squared minus 1 dx is equals to the definite integral from theta 1 to theta 2 of g theta d theta. So you need to get the theta 1 and theta 2 exactly, and then your g is just a single trigonometric function in terms of theta to be determined. Okay, when they give you that substitution, x equals to secant theta, first thing you differentiate respect to theta. So dx d theta is secant theta tangent theta, understand? And then because you are doing a change of variable here from dx to d theta, you need to sub x equals to square root 2, okay, in here. So square root 2 equals to 1 over cosine theta. You solve for the corresponding theta. Follow? You sub x equals to 2 in here. So 2 equals to 1 over cosine theta. You solve for the corresponding theta. So that means that your definite integral in terms of x will be, instead of square root 2 here, will be pi over 4. And instead of 2 here, it will be pi over 3. Okay? And then you replace everything with the substitution process. So your x is secant theta, it will be 1 over secant square theta minus 1. Okay, your dx is dx is secant theta tangent theta times d theta in a sense. Okay, now this is from your trigo identity. Okay, now I want to point out something to you. When you square root something, it has to be non-negative. Agree? Meaning at least 0. So here the square root of secant theta minus 1, right, is square root of tangent square theta, just trigo identity. But from here to here, you have to put modulus. Because when you square root something, it has to be at least 0. So you put a modulus here to ensure that. But why we can remove the modulus, right, by writing it as tangent theta, is because when theta is in this range, right, your tangent theta is in a sense positive. You get it or not? So I can just remove the modulus. Are we clear? So the nasty question, right, would be when your tangent theta is negative in, maybe, let's say, should I say this? I don't think it will be this nasty, but I should say this since I already said. So let's say if your theta is more than minus pi over 2 and less than 0, your tangent theta is negative. So if you want to remove the modulus, you must put a minus in front of the tangent theta. Understand? Yeah. Okay, so you cancel tangent theta, and then that will be your answer. Okay. Part B, hence find the exact value of this definite integral over here. So we make use of the change of variable, right? So the exact value of this definite integral is just the exact value of this definite integral. And integrating this will give you, okay, modulus again. So if you don't feel very, if you feel very afraid that, is it negative or not negative, then never mind. You simply just put the modulus, understand or not? But in fact, it is positive inside in the expression. So the answer is just this. Any question on question 5? Nope. Okay, so we are halfway there. We move on to question number 6. Okay, 6. The functions f and g are defined by fx to be ln x plus 4 whole thing square minus 9 for x more than k, and gx 3 minus 2x over 1 plus 2x for x at least half. Find the least value of k for which the function f inverse exists. Now, can I ask you to plot this in your GC now? Just to do it quickly. Because if I tell you the answer, it will make sense to you. So my pro tip number 1, if you have a function explicitly given to you in your exam, right, plot it. Okay? Visualize it first. So you will get a graph that looks something like this. Do you? Okay. So if you notice, right, the two vertical asymptote over here have, right, in a way, just kind of like make a smart guess. So I'm not going through the algebra, but I'm going through the pro tip for you. See an explicit function, plot in your GC. So I want f inverse to exist, meaning that the function, original function, I need to make sure that any horizontal line cut at most once. So I need it to be here onwards. Okay, question is, how do I know what is the equation of this vertical asymptote? Now you know that using your logarithm knowledge that anything inside the ln must be more than 0. Okay, and then you solve it. I'll leave it to you to solve. Oh, the function is only defined when x is less than minus 7 and when x is more than minus 1. Understand? So then your minimum k would be minus 1. That's it. Okay, use this value of k found in part A for the rest of the question. So without finding f inverse, this one you can put a star. Perhaps it's quite important. Why A level maybe test this is because they want you to know how f inverse and f relates. Very important. So if you want to find the exact value of alpha, if g of 3 of 2 is equal to f inverse of alpha, right, you apply the function f on both sides. Understand? You compose again, and then f of f inverse alpha is alpha. This is the one that they want you to see. Okay, and your g of 3 of 2, you sub in 3 of 2 inside, you get 0. So f0 equals to alpha. You sub the 0 here, so it will be ln 0 plus 4 whole thing square minus 9. Alpha is ln 7. Okay, no issue. Now we go on to the next one. Next one, the function h is defined as such where a is a constant sketch the graph of y equals to hx, stating the coordinates of the stationary point and the equation of any asymptote. Pro tip, you always remember, you can let a be 1 and sketch the graph out. I'm just going to emphasize this again. If they give you the graph, you be that student who use your GC, don't straight away dive in the question. A is unknown, I know. You can always let A be a value and then you sketch and then see how it looks like. Very important, because the moment you can visualize how it looks like, right, you are almost certainly able to understand the question more or less because you know what you are handling. Okay, so then the graph will look something like this in your GC. Okay, then you put the unknown A back later. So you know that the curve looks something like this, right? And then you see that, hey, the graph tends towards certain line, right? Vertical line. So what happens here? You solve for the stationary point. Very simple. You just do the first derivative. You equate dy dx to 0. You solve for the x coordinate of the turning point, which is the minimum point. Sub in the original equation, get the y coordinate. Any question? Nothing much. Equations of the two vertical asymptote is very straightforward. What is the value of x that makes the denominator 0? X equals to 0. What is the value of x that makes the denominator 0? X equals to 8. And then you label the equation of the two vertical asymptote. Remember that? Label the x, label the y-axis, label the origin, and then label the minimum point. Okay, that's 3 marks. Any question on that? So now we move on to 6D. Given that the composite function GH exists, find the range of values of A. So when you are asked to do this question, right, again, you should put a smile on your face. If they ask you to, if the statement is along like this, right, and they ask you whether the composite GH exists, you need to make use of the condition that R of H, the range of H, is a subset of the domain of G, which I mentioned here. So first thing first, let's list out the two functions, which is here Gx and Hx, okay? So the range of H literally is from square root 2 over A all the way to infinity, agree? And then the domain of G is half to infinity. Remember the square and the curve bracket. So for GH to exist, the range of H must be a subset of domain of G. So in order for that to happen, you need to make sure that this is at least half. Agree or disagree? Then you will solve for your A, and some point to take note, because you're dealing everything that is positive, right? A is positive, by the way. So you flip this fraction, you change the inequality, the sign, understand? And then you solve for A, and noting that A is more than 0, then your A is more than 0 and less than or equals to 8. That's it. Okay, part E is an interesting one. So part E, by considering y equals to 1 over hx and its stationary point on or otherwise, find the value of A for which hx whole thing square equals to 1 has only one real root. So we have method 1 over here. Hx whole thing square equals to 1, right? Let's rewrite as hx equals to 1 over hx. So we consider the two curves, y equals to hx with this minimum point. So y equals to hx with this minimum point, right, is the one that I have drawn just now, remember? And then I consider now I have the graph hx here. And then I also plot the graph of 1 over hx over here, which has a maximum point of a over 2 and square root a over 2. Do you know how I get square root a over 2? I simply flip this one. Agree? Because I flipped the thing over. So now that I have these two graphs, in order for them to... Oh, by the way, you know how these two graphs look? Why is it like that? Again, you let a be 1, and then you plot out 1 over hx, which is... You know what I mean? You can plot this out to notice that, hey, actually it's a smiley graph. Sorry, it's a set graph. Understand or not? Then you know that. That's why you have to plot out. Even for this, right, you need to plot out. So if you want them to have only one real root, means that both the minimum point and the maximum point of y equals to hx and y equals to 1 over hx respectively intersect exactly 1 point. So that means that how do you force that to happen? When your square root 2 over a equals to square root a over 2. Agree? Agree? Then you solve for a plus minus 2. Since a is more than 0, a must be equals to 2. Question? Now for the typical method, if you are not confident on doing that because they say or otherwise, then what we do, right? We simply do this, the algebraic method. So hx here is actually just equals to x bracket a minus x bracket whole to the power minus 1 over 4. So we plug this in here and then we square it. Okay, we do the indices and then we write it in ax squared plus bx plus c form. And then you do the discriminant for repeated root, b squared minus 4ac equals to 0. You solve for a, you will get the same thing. Okay, that's the second method. Okay, basically this is just your A math discriminant question. Got it? So that is for question number 6. Question number 7. It is given that fx equals to ax to the power of 5 plus bx cubed plus cx, where a, b, and c are non-zero real constant. 7a, show that f minus x equals to minus fx. So we replace all the x here with minus x. And then through an algebra, you will notice that f minus x equals to minus fx. Okay? Part B. Okay, this one I'll go through slower. It is given that fx equals to 0, has only one real root, and one of the non-real roots is p plus qi, where p and q are non-zero real constants. So they don't care about the real root. They want you to find the non-real root. Find in terms of p and q all the other non-real roots of fx equals to 0, justifying your answer. So the fact is that fx equals to ax to the power of 5 plus bx cubed plus cx, right? So fx equals to 0. Since all the coefficients are real, we use the conjugate root theorem. If p plus qi is a root, then the conjugate p minus qi is also a root. 1 mark. Now here's the hard part. We know that, this one will be harder, from part A, right? F minus x equals to minus fx. So if I say that f minus x equals to 0, then equivalently I can say that minus fx equals to 0, right? Then I multiply both sides by minus, I say that fx equals to 0. Which means to say, this equation and this equation tells me that knowing the root, so x is the root, correct? If I replace the root with the minus of it, it's also 0. Agree or not? Can see where I'm coming from? So originally when fx equals to 0, right? I know that when x equals to p plus qi and p minus qi, I will get right hand side to be 0. That's the definition of root, right? And I also know that fx is equals to 0 is the same thing as f minus x equals to 0. So all I have to do is to replace the x here with minus x, and the roots will still be valid in the sense that that will also be the root as well. So I replace the p plus qi, put a minus in front. So I have another non-real root, minus p minus qi, and here also I put a minus in front, minus p plus qi. Interesting. So that is for 7b over here. Any question on that? This one is tough. This one is tough. Okay, let's move on to 7c. Right, 7c, given that the definite integral from 0 to 3 of fx dx equals to minus 5, state the value of the definite integral of these two definite integral. Okay, first thing first, we draw it out. Okay, so we're going to draw this out. Okay, so if we draw this out, right, it will be, okay, you may ask me how you know the curve is like that. Okay, that is a valid question. So you can simply let a, b, c be any value in your GC. You can do it now if you want. That's why you should use your GC. when given a function with unknown, right, you can always let A be 1, B be 1, and C be 1, for example. And you can just plot out anything you want in your GC, so you roughly know the curve, how it looks like. But all things being said, right, I know the curve is like that because this is an odd function. You know what's the meaning of odd function? Odd function means, right, f of minus x equals to minus fx. That's in essence what it means. So that's the meaning of odd function. Okay. So let me maybe elaborate to you a little bit more why I think the curve is like that. But you should use your okay. First thing first, for students, cheat method is you let your ABC be certain value, you roughly know the graph. Okay. The odd function is like that is because let x be 1, okay? So okay, let x be 3. So f of minus 3 equals to minus f3, agree? So this is minus f3. Can see? Then this is f of minus 3. Sorry, this is f of 3. Follow so far? And then in a way, if I put a minus here, this will be equals to this. Can see? Yeah, so I wanted to just explain this part over here. So that's the meaning of odd function. That's it. Nothing much over here. Okay? So once you draw the graph, right, you need to know how the graph looks like. I know that the definite integral from 0 to 3 of fx dx is minus 5. What about the definite integral from minus 3 to 3 of fx dx, which is here? Well, you know in your A math that for odd function, right, the area here and the area here, they negate each other exactly. So the definite integral value is just 0. Agree? Because odd function is symmetrical in some sense. You get where I'm coming from? How it's symmetrical is you think about it this way. You flip this graph about the x-axis and then you flip it about the y-axis. That's the meaning of odd function. And then the region here and the region here, they share the exact same value if you take the modulus, just that one is the negative of the other. So it negate each other off. Okay? Now, how do you... Sorry? We are not finding area here. Remember in A math, we never ever do the integration as a whole. We always split into different interval. Okay, so if you want to find the area, it would be like this. Since you're in JC now, last time I never do this, right? I put the minus in front. Yeah, this is how you do. You split the two intervals. But we're not finding area here. We are simply, I want the definite integral, which I told you before is not always the area, remember? The definite integral itself is not always the area, depending on how the curve looks like. Sure? So now we want to find the same thing, but we replace the x with modulus x. Do you still remember your graph and transformation? If I replace x with modulus x, you know what happens? It means that you flip so this is the original graph. I keep the graph on the positive part of the x-axis, and then I reflect it about the y-axis. So I'm looking for this region over here, which is just minus 10. Because it's like you add the negative 5 with the negative 5, which is minus 10. Agree? Okay. So this will be question number 7C here. Okay, 7D. Let A equals to 1 and B equals to 3 by considering f prime x. Find the range of values of C such that the curve with equation y equals to fx has two stationary points, showing your workings clearly. So we differentiate after letting A be 1 and B be 3. At stationary point, 5x to the power of 4 plus 9x squared plus C equals to 0. What I do here, right, is I rewrite it as 5x squared whole thing squared plus 9x squared plus C equals to 0. So in a way, in a sense, this is like in the form of ax squared plus bx plus c equals to 0. Then now you treat the x squared as that variable. So use the quadratic formula. So x squared equals to minus b plus minus squared b squared minus 4ac over 2a. We reject this because your x squared must be non-negative. So if you want two stationary points, you need to make sure x squared is positive. It cannot be equal to 0, understand? Because you need to find out 2x value. After solving this equation, that x value is the point on the stationary points. So you need 2x value to have two stationary points, which is what the question wants you to do. And then you just solve it. You get c to be less than 0. Any question? Again, it's just algebra. Okay, we are done with question number 7 over here. Question number 8 over here. A curve C has parametric equations x equals to t square, comma y equals to ln t for t more than 0. Very important because logarithmic ln is defined for t more than 0. Okay, 8a, simple lah. Find the equation of the tangent to C at the point perimeter t. So t, in a way that is exactly, so in a way you can think about it as the coordinates, right, of this tangent to the C, it will be at t square and ln t, understand or not? So, okay, same thing, do dx dt, do dy dt, dy dx take dy dt divided by dx dt, 1 over 2 t square, right? So at the point with parameter t, the equation of tangent here is just basically, you know, y2 minus y1 over x2 minus x1, understand or not? And then the gradient is 1 over t squared. So if you bring this over, it's simply just y2 minus y1 over x2 minus x1 equals to the gradient. Got it? And then you just do algebra. We are done. Okay, I'm not going to go through the algebra. Can 8b. The line is the tangent. So this same line over here is the tangent to the curve C at this point, P, which is P squared ln P. So by observation, you would know that T must be P. Agree or not? So actually, the equation of L, the tangent at the point P, is you sub your T over here with P. Understand? So you need to observe that. Then now you need to solve for the P. How? Because given that the line L passes through this point, where x equals to 1, they sub in 1, and y equals to p squared plus 1 over 2p squared. Solve for ln p, p equals to e. Done. Any question? Okay, very simple lah. It's very fast. Because I don't know what to say, but just a refresher. Okay, part C. Find integrate ln x dx. So I purposely, the answer key did not write it my way, but I purposely put the 1 in front of the ln x. Okay, so what happens here is LIATE, u is ln x, right? This is v, right? So keep u, integrate v. So integrate 1 is x, understand or not? Minus integrate, differentiate u, integrate v dx. Then this is just integrate 1 dx, so minus x, then plus c. Any question? So that will be 8c. Okay, fast and furious. Now, the reason why they have part C, right, is now they show you everything. They have the parametric curve C drawn for you over here. Very nice of them. And then they have that equation of the tangent, the line L at point P. Okay, so they want you to find the area of the shaded region bounded by the curve C, the line L, the tangent, and the vertical line x equals to 1. So first, to find this, right, we need to find out the Cartesian equation of the curve C. So this is the parametric equation. So what we do, now we note that t is more than 0, right? So we can just say that, hey, we take the square root on both sides. So t equals to square root x, no issue, right? Then y equals to ln t. Now we plug the t here with square root x. So y equals to ln square root x, which is half ln x by the power law. And then the area bounded would be, okay, we remember, if you remember, the point P here, okay, let's go back and recap our memory. So so just now you solve P equals to E, right? Agree or not? Just now you solve P equals to E, right? So when you solve P equals to E, then what happens here is, where do you think this point P is? So P equals to E, right? So in a way, you can think about it this way. Your P here, the x coordinate will be E squared. Any questions so far? Because your P equals to E. Understand or not? Okay. So to be more specific, E squared. Can see? Okay, so now we have this. We just do the integration. Area bounded will be the definite integral from 1 to e squared. Take the curve on top, or maybe not, I say the curve lah. The tangent on top, the equation, minus the curve C below. Understand? And okay, here I skip a bit of step lah, but I'm not going to go through this. Just do your integration normally. I won't bother going through this, can? You all can take your time and go and work it out yourself. Okay, so even better, if you want, you can redo the questions if you feel confident. After listening, you think that you understand, but maybe when you do it again, it's a different story. So work out the algebra yourself. Right, 9A, vectors question. This was in your school paper, but much harder. This one is the hard one. Harder than your one. Not say harder, it's a different context. Okay. A right triangular prism has its two triangular faces ABC and PQR adjoined by three rectangles as shown in the diagram below. The coordinates of the points A, B, and C are given as these 3 points here respectively. Part A, find the area of triangle ABC. Okay, very simple. The coordinates of the points are also the Berzelian vector. So I write out the Berzelian vector for you as like column vector lah. Then after that, we find the directional vector AB, AC, we take their cross product. And then the area of triangle ABC will be half times the modulus of the cross product of the directional vector AB and AC. Okay, do yourself. That's the area. Okay. Now, 9B. Find the Cartesian equation of the plane which contains ABC. Very simple. Okay, so we know that AB cross AC in a way is the vector perpendicular to ABC, right? And you want the Cartesian equation of the plane which contains ABC. So then I would say that a normal vector to the plane which contains ABC, that normal vector must be this, right? But remember, do not use big values. So here I'll take out 10. So in fact, it will just be 1, 0, minus 2. Understand or not? So you use that as your normal vector to ABC, and then invoke your r dot n equals to a dot n. Your normal vector, put here, big one Berzelian vector, a point on the plane. Okay, the Cartesian equation of the plane which contains ABC. I choose A here. After that, a dot n dot the normal vector. Do they want the Cartesian replace this vector r, that is the Berzelian vector of any point on the plane with x, y, z. Then you have x minus 2z equals to minus 7. Questions? Yeah. So 9C is the hard one. I think the reason why these days the prelim papers are giving this question is because it hasn't come out yet. So there may be a chance it comes out. So if you know the way to do, then it's very straightforward. So if you don't know how to do it again, whoa, I think maybe I will not be the one feeling sad. So nicely, it is given that the plane which contains PQR has equation r dot n. Notice that the normal vector is the same as the normal vector of the plane containing ABC, right? So this r dot n is minus 2, this r dot n is minus 7. So basically, the plane containing PQR and the plane containing ABC both has the same normal vector in the same direction. This matters, by the way. Okay, so far, the questions I have seen, they are very nice. Okay, because both their normal vector are pointing in the same direction. So you will have these two planes parallel to each other. Okay? So when both their normal vectors are pointing in the same direction, right? Then what you do is for this two plane equation, right? Containing PQR and ABC, which is written here, we do a standardization. We divide by the length of the normal vector, which means that the right hand side also divide by the length of the normal vector. You follow? Then the perpendicular height of the prism, right? I have explained this in the ACJC paper already. You simply take the difference. Okay, you simply just take the difference. You can do it in any direction. It doesn't really matter. So you take the difference. So how you do? I tell you. Okay. For the students who just want to score the marks, never mind. you use the r dot n equals to a dot n formula first. You write the equation of the two planes in r dot n equals to a dot n format here. And then next step, for these two equations, you divide by the length of the normal vector. Understand? And then once you do that, you make sure the right hand side, you also divide by the length of the normal vector. Now, if both their normal vector are the same and pointing in the same direction, then you take the difference of these two values. Make sure to put a modulus. That will be the perpendicular height of the prism, which is also the distance between the plane containing PQR and the plane containing ABC. Understand or not? Okay, just a casual remark. If the plane are pointing in opposite direction, meaning towards each other, then you sum up these two values instead. And then you take the modulus. It's in my notes, by the way. Yeah. Anyway, I know that when I went through that notes, I know that the students will need to come back, revisit again. Okay. So yeah, I want to mention that if this will be a hard question, don't worry if it comes up. But if the normal vector they are pointing in the same direction, right? You take the difference. If they are pointing in different directions, meaning pointing towards each other, then you take the sum. Okay, the math works out, by the way. It's a matter of the math works out. Don't worry, I proved it. So once you have the perpendicular height of the prism, right? The volume of the prism is just the cross-sectional area, right? Which is the area of triangle ABC is 5 square root 5 times the square root 5, the perpendicular height. That will be the volume. Put units cubed. Any question? Right, part D, find the coordinates of P. This is quite simple actually. What you do, right? I tell you the general answer. You find the equation of the line AP, and then you plug the equation. Then, okay, once you find the equation of the line AP, right, then a point on the line AP, you write as a single vector for some lambda, and then you sub it into the equation of this plane here. Remember? So that is how we do it. We let P be the foot of the perpendicular first of A in a way. You look at it the other way lah. Then the line AP, right, okay, will be this equation with Besselian vector A plus lambda times the directional vector of the normal vector perpendicular to the plane containing PQR. Follow? For lambda, remember a real number. Then that means that point P, right, has to be minus 5 plus lambda minus 4 and 1 minus 2 lambda. For a sum lambda, there's a member of real number. Understand? And then we sub this into the equation of the plane PQR. Understand? And then we just solve for lambda, we plug it in here, and then we get that point P. And then remember to write as coordinates. This is the part the student always forget. If they want the coordinates, you don't give in the Besselian vector, you write this. Okay, that's it for D. I'm very happy with the progress because I know I will finish it. And we're going to do this concurrent with your other lesson. And then I hope you familiarize yourself with all the standard methods. Okay. Oh, by the way, you do have to do this is just the understanding part. 9E, a circle with center O here passes through A and another point D with coordinates 1, 5, minus 4. Find the length of the minor arc AD, okay, giving your answer correct to 3dp. Okay, arc length formula is r theta, where theta is in radian. It's okay, I'm not going to be using that formula. So I do know that I have my Besselian vector OA and OD written down here. Okay, let the angle between OA and OD be theta, which is this one. And then I use the dot product formula, scalar product formula. OA dot OD equals to mod OA mod OD cosine theta. Solve for theta. Here, right, it's not AMF, it's not the basic angle anymore. You can do that, but here you just simply take the cosine inverse of the negative 29/42. Okay, it's a straightforward method to get the angle. You can do the basic angle, but later you have to draw the ASTC. You will still get the same answer. So just straight away do it. So the angle here, subtended by the arc AB, is this. Then the minor arc is that angle, 133 point something, divided by 360 times 2 pi r, where your r here is given to be square root 42. Understand? Which is your length of OA. Got it? Done. So that will be 9. Okay, question 10. Am I fast? No? Hope you know the standard steps. I'll give you a standard paper towards the end. But slightly harder. In a particular chemical reaction, every 2 grams of compound Y and every 3 grams of compound Z react to form 1 gram of compound X. So let X, Y, Z denote the masses of compounds X, Y, and Z respectively, present at any time t in minutes after the start of the reaction. 24 grams of compound Y and 24 grams of compound Z are used at the start of the reaction, and there's none of compound X present initially. Part A, express Y as alpha plus beta X, where alpha and beta are constants to be determined. So we have Y equals to 24 minus 2X. Make sense? Because to form 1 gram of compound X, right, you will need 2 grams of compound Y. Okay, so initially you have 24 grams of compound Y. Okay, so every 1 gram of compound X would require 2 grams of compound Y. So 24 initially minus 2X. Understand? Now, part B. At any time t, the rate of change of X with respect to t is directly proportionate to the product of Y and Z. Show that this differential equation holds. So you need the Z as well. Because I got my Y, right? I also need I got my Y in terms of X. I also need my Z in terms of X. So here is the statement. Every 3 grams of compound Z react to form 1 gram of compound X. And there are 24 grams of compound Z. So Z equals to 24 minus 3X. And then we do the proportion now. dx dt equals to K1 times YZ because it's directly proportionate to the product of Y and Z. Where K1 is a positive constant, Y is because your X is the compound that is increasing in mass. So K1 has to be a positive constant. So dx dt would be K1, you plug in the Y, you plug in the Z, okay? And then what you do, okay, I'm not going to work out the algebra, but I do want you to know that you need to show it this way, right? So you take out the minus 2 from here, you get X minus 12, you take out the minus 3 from here, you get X minus 8. Minus 2 times minus 3 is 6, K1, we redefine it as K. And then now we say that K is a positive constant. And then we have our X minus 12 and X minus 8 over here. Any question? Yeah, that's the part. Okay, 10C. By solving the differential equation in part B, find an expression for X in terms of T and K. So I told my JC student always, the X on top suggests that you must put the variable to the left. Okay, that is how you remember. Whatever that's on top, right? If it's X on top, you need to shift all the variables of X to the left. Shift meaning you divide, don't subtract. Okay, once you shift and then you integrate, you get this part over here. You integrate both sides with respect to dt. You will get this step over here, and then you do the completing the square over here. And then you apply the formula for the integration. Got it? You can actually do partial fraction here as well. Just saying, depending on your preference, can? And then once you go until this step over here, right? Then here, then you take the modulus out. That, by the way, there's a difference if you take the modulus. Okay, just always remember, for safety's sake, you take the modulus at this step. Don't go and do extra other way. Some of your notes got mentioned this, right? Your modulus, take it over here, can? And then now you have that. Okay, you do the e to the power of 4kt plus 4c, and then you remove the modulus, so plus minus. Okay, use the indices here. And then you always redefine the e to the power of 4c plus minus e to the power of 4c as a. Got it? And then now, because they say that there is none of compound X present initially, means that t equals to 0, X equals to 0. Sub it in this equation here. Solve for your a, which is 3 over 2. Plug it in. Any question? And then you make X the subject. I'm not going to walk through the algebra with you. Okay. Part D, state the theoretical mass of compound X formed in the long run. Okay. The answer is actually very. They just gave a one-liner, but I would like to explain this to you. Maybe you could put a star here. This is a trick. This is a tip. if they ask you for the long run, right, there are two types, easy question and hard. This is slightly harder. Okay, so what you do, right, if you take a look at this x, right, you know that in the long run, you need t tends to infinity, right? So if you take a look over here, if my t tends to infinity, knowing that k is positive, right, this exponential expression would blow up to infinity. Then how do I know what value x will be, right? The theoretical mass in the long run. So what I do is, right, for x equals to this, I purposely multiply the top and bottom, this is the pro tip, by 1 over e to the power of kt, understand? So then I get this expression over here. This is the pro tip. And then now, once you do that, then you say that, hey, as x tends to infinity, I know that 1 over e to the power of 4 kt, knowing that k is positive, right, will tends to 0. So this becomes 0, 0. So your theoretical mass of k is minus 24 over minus 3 is 8. X approaches 8, so the theoretical mass is 8 grams. Any question? Okay, now we do part E. It is observed that there are 4 grams of compound X formed 5 minutes after the start of the reaction. Determine the exact value of K. Sub T equals to 5, sub X equals to 4 in this equation here. Okay, in this equation here, then you solve for your K. Again, you just work out the thing yourself. Okay, part F, sketch the graph of X against T with the value of K found in part E. Okay, so what you do, you treat the GC, right? You know the GC, that Y, right? Your GC is always Y. You cannot change that thing, right? So that Y, you treat it as your X here. You understand or not? So basically, you think of your Y in your GC has the X here, and then the X in your GC has the T here. Are we clear? You plug the K in, and based on part E, you know that the theoretical mass approaches 8 grams. So draw the horizontal dotted line, the asymptote, x equals to 8. And then you just follow your GC can ready and must start from the origin because the mass initially is 0. So that's it for question number 10. Wow, so fast. Okay, question number 11, put a star. Right, I'm going to read this quickly, okay? Volume of a right square pyramid base is 1/3 base area height. Okay, Jane designs a model in the shape of a right square base pyramid. The square base has sides x cm. Each of the 4 lateral faces is a triangle with base x cm and perpendicular height l cm. The 4 lateral faces converge at the top of the pyramid to form an apex directly above the center of the square base. The vertical height of the pyramid is h cm. The model is assumed to be made of material of negligible thickness. Part A. Form an equation involving x, l, and h. Giveaway. Pythagoras theorem. Got it? This part is x over 2. 11b. Oh, B and C. C is quite algebraic. This question is very, very algebraically intensive. So maybe I'll go through a bit. But you can do it yourself after listening to see whether you can do or not. I would suggest you go back and do. You understand, right? See you can execute it. If you don't have time, you do this. Important. But if you don't know how to do, then you know, oh, this is where I don't know. In the design of the model, Jane hopes to fix the total surface area A cm cube of the model, but maximize the volume V cm cube of the model. Okay, using the result in part A for part B, show that the area of this right square pyramid has such, very simple. The area A is the area of the square below plus the area of the 4 lateral sides of the triangle. So A equals to x squared plus 4 times half times base x times my perpendicular height to the lateral side of the triangle, which is L. Which L squared is this, right? So L would just be square root of h squared plus x squared over 4. Understand? Just do your algebra here, you get the answer over there. Any question on that? Okay, 11C. Oh, got question, is it? 11C. Hence, using that, show that your V squared, the square of the volume, is given by this expression. So what you need to do, right, is first, we know that the volume is 1/3 base area times height. So the reason why the question asks you to show part B, right, is so that you can, remember in differentiation, make h squared the subject. So you work out the algebra yourself, okay? So h squared is given to be this. Then, so I advise you, now you think of the idea, right? You see you can execute it in your algebra. Trust me, there's a difference. So now you have h squared to be this. And then what's next? Volume of a right pyramid is 1/3 base area height, which is v equals to 1/3 x squared h. Now we are looking for v squared. We square both sides. Okay? And then now we plug in the h squared that we have found earlier, which is here. Any question? And then you work out your algebra, you do... Okay, by the way, although I'm going through the answer, in your A-level differentiation, right, you must remember the left-hand side is the variable and the right-hand side must also contain one variable. So left is v, right is x, a is a constant over here. Understand or not? A is a constant over here. Because Jane hopes to fix the total surface area ACM square of the model, but maximize the volume VCM of the model. Do you actually catch this statement over here? Okay, it's very important. Okay. Anyway, your A-level differentiation, right, will always be one variable on the left and one variable on the right. If you don't have this, you better relook at your working. But it allows for other constant like 2, 4, A over here. Okay, very important points to take note. Okay, so work out the algebra, you show that V squared has such. I'm not going to go through this. Okay, part D, use differentiation to show that the maximum V occurs when x equals to square root A over 2 and find a simplified expression for the maximum V in terms of A. No need to show that it's a maximum. So if they never ask you to show, you don't need to use the first or the second derivative to show. Okay. However, I'd like to tell you that if the first derivative expression is complicated, try not to use the second derivative. Use the first derivative method. You know how, right? In A level, it's harder than A math. You know this thing? You should have done it before, right? Correct? Like that. Your A level differentiation is no longer numerical. It will be like that. Okay, so I'm going to point this out to you. This paper is nice because they put V square. If your A level give you this, if you do dA dx here directly, you will feel the pain of very painful algebra. So always remember whether you can square it and use implicit differentiation. This is what I'm going to tell you. It's not about going through the answer. I want to point out all the important things that you need to know. Okay, don't do dv dx over here if given this expression in blue. Well, you can, but you look at this expression, right? If you do dv dx here, you'll be very sure you know what you're doing. Okay, I'm going to tell you, I'm not going to lie, this expression is not so easy to do. If it's me, right, I will expand this thing inside first. Then I differentiate. You understand or not? Say, so square it. A level may ask you to do, they will not tell you to do that, but you need to figure out that that may be the way to do implicit differentiation. Understand? Hey, by the way, for the record, right, I start from this. I use this, by the way. I use this, by the way. Don't start from here and do product rule. Expand here and differentiate, okay? Okay, then you differentiate. Okay, at stationary point, dv dx equals to 0. Solve for your x. Okay, you just do it yourself lah. You will get square root a over 2. Follow? And then the maximum v, you find the maximum v square first. So what's your v square expression originally is here, right? So replace the x over here with square root a over 2. You understand? And then it's just really just algebra. You work it out yourself at home. Best is you do it after, when you have, maybe tomorrow, the day after tomorrow. Okay, you do. So your maximum v is a cubed over 288. So maximum v is square root a cubed over 288. You will get this to be your maximum v. Understand? Okay, part E, last question for this paper. Given that v is a maximum, find the angle made by a lateral face at the base of the model, giving your answer to the nearest degree. Oh, this is, so they want you to find the angle when the volume is maximum. So 1/3 x squared h is the maximum volume here, square root 2 square root a cubed over 24. So what I want to do, right, is I know that this is how the two-dimensional, the 2D looks like. Let the angle, the lateral face make the horizontal be theta. So I know that the bottom is x over 2. This is theta and this is h, right? So what I want to do is to find h in terms of x. So that's what I'm doing here. 1/3 x squared h is square root 2 square a cubed over 24 because they say find the angle when volume is maximum, make h the subject, which is square root 2 square a over 2, right? Okay, plug it in here. Before plugging in, tangent theta is O over A, which is 2h over x. Now we plug the h, which is square root 2 square a over 2. And then we plug in the x that maximizes the volume, which is half square root a. Got it? You simplify it, find the theta, which is 71 degrees. That's the nearest degree. That's the answer.